All right, guys, here's the video I was telling you about. The one on Schoology is just very long, and whenever I get the chance, I'd like to make the videos from me since I'm your teacher anyways. So it's called Factoring Completely. And like I was telling some of you, it's something we already know for the most part. You need to make sure that you always check to see if you can factor further. So I'm going to show you what that looks like. So make sure you have your notes open, the yellow binder, page 6-15. And there are 4 examples that we're going to go through. And like I said, I just want to make sure that we all are on the same page. It is something I have talked about before. And if you have your index card, you should get it out with you. But it's the reason we went the way we did on our index card. When you're first presented with a polynomial to factor, you should always check for GCF. That is always the first thing you should do. You might still be able to factor something, and you will then think that you are correct because you are able to factor it, but you might not have factored it completely. And what I try to tell students this is like, it's almost like, and I think I've used this analogy before, but it's almost like if you have the expression 4/8 and you simplify it to 2/4. Well, that's correct. You did simplify it, but you didn't simplify it completely, which would be simplifying it to 1/2. Same idea here. If you forget to check for a GCF and you factor, well, it's a good news, but if you didn't factor completely, you don't have the right answer. So always check for GCF first. And then after you factor that out, you want to look at what remains and you see if that factors again. So you essentially check all of your factors. Always check your factors. Every time you factor, check all of your factors. So if I start with example 1 here, and I notice that the GCF is a 2. So I factor my 2 out, and it would leave me with an m squared plus 15m plus 54. Now, I have 2 factors. I have the factor in yellow here, the obvious one, but believe it or not, this is also a factor in green here. They're both factors because factors by definition are the 2 things that multiply together to give you something else. Well, they multiply together to give me 2m squared plus 30m plus 108. So by definition, they're both factors. Now, 2 doesn't factor. But what I would want to check is in parentheses, now look at that. That looks like a standard trinomial, which definitely does factor again. What multiplies to give me 54 that adds to give me a 15? Well, that factors as m plus 9 and m plus 6. Bring down my 2. And now I actually have 3 factors. I have what's in orange here. I have what's in blue. And I have what's in yellow. So I actually have 3 different factors, and I would want to check all 3 of them to see if they factor again. Well, the 2 still doesn't factor. The m plus 9 doesn't factor. It's a binomial, but it's not a difference of perfect squares. And m plus 6, also a binomial, but not a difference of perfect squares. So my final answer, I would write that 2 out front, and then in any order, m plus 9 and m plus 6. Okay? So again, something we've actually looked at before in our notes when we were doing difference of perfect squares, that one question that was hidden in there on us. But that's essentially it. So you just always check, can I factor further? I get to example 2. Always check for GCF. I find that my GCF is a 4. Factoring out that 4 leaves me with something in parentheses here that can factor further. What are factors of 24 that add to give me a negative 11? That would have to be a negative 8 and a negative 3. I bring my 4 down from out front. None of these can factor further, and so that is my final answer. And so that's what we're doing. We're checking constantly. Can anything factor further? I told you, I already warned you. Your bonus question on the Unit 6 test, which as of now is planned out to be the 2nd day after your return, January 5th, 2021. The bonus question is a polynomial that you can factor 4 times. Okay, so you should just always check, can I factor further? Get to example 3. Always check for GCF first. That is what you always do first. I find that my GCF is a 5, leaving me with a p squared, and 320 divided by 5 is 64. Yep, p squared minus 64. I look at what's left over in parentheses, and hopefully you notice that p squared minus 64 is a difference of perfect squares, right? Difference, both of those perfect squares. That factors as a p plus 8 and a p minus 8. Don't forget to write your 5 down. The p plus 8 and the p minus 8 cannot factor any further, and so I have my final answer. And so again, like I said, you always just check, can it factor further? And look at example 4 here. I definitely recognize that 4 is my GCF, but also part of that 4 is also the b that they all share. So my GCF is actually a 4b. When factoring that out, I'm left with a c squared plus a 3c minus 10, which can be factored further. C plus 5 and c minus 2. And then just don't forget your GCF of a 4b. None of those factors can factor again. And so I'm down to my final answer. Okay? So the main gist of this, again, we've talked about this already. And the reason why I wanted to make this video, because I feel like I was able to do it as quick as I did. And you guys have impressed me. It feels like majority of you know how to factor. I guess we'll find out when I see that quiz. But you just need to check, can you factor further? Always check your factors. Always check what's in parentheses. Can I factor it further? So that's it. Just those 4 notes examples. Quick video. And then if you would flip the page, it goes to 616, which I believe is blank. And 617 has 20 questions on it. And so right now, you should do numbers 1 to 20 on page 617. And that's what you're going to do. Okay? Let me just double check before you leave that that is correct and accurate. Page 617. Yep, 617 has 20 questions, and that's what you're working on right now. So go ahead and you can get started on that.